So this is the AppArmor update for 2025 activity. We actually have some development activity. It's great. This is a full year from the GitLab. For the user space side, this doesn't count the kernel. We have like a fair number of commits. Some days we even have like up to 40 is the top one, 46 commits in one day. This is a 6-month window that helps show it a little better. We actually topped out. I didn't run the actual Git check, but I just used the GitLab analysis. We did more than 2,000 commits. So it just says 2,000 in 6 months, 141 different unique contributors in 6 months. So, I mean, we actually have some decent activity going on, which is really nice to see. First thing we're going to cover some changes we did to the CI/CD pipelines that we have running. We had Zyga from the Snapd team, Snapd project, come over, and he did some work on our CI/CD, brought in spread and image garden. So what happens now with our CI/CD, instead of just running in containers for the different commits, this user space stuff, for every commit we're spinning up VMs, running different images, different kernels. We can run an Ubuntu image, a Red Hat image, a Debian image, whatever, so we can have multiple tests and regress, not just the regular stuff, but actually in use. So our profiles and stuff, we can have individual tests attached to them so that we know that when we do an update, it'll check the profile, make things sure that whatever the test is for that application, that the application's run and it's run with that confinement in different environments. And so, yeah, it takes a lot of CI time in that sense, but we're getting a lot better CI out of this now, which is really nice, making sure that we're not broken all the time, trying to come back and fix things. Mediation, there's not a lot of mediation that has landed in the last couple years. We've been kind of blocked on reworking the AF Unix stuff. Over and over and over again, continually making changes. So for a long time, Ubuntu's carried an AF Unix mediation, but it always had some issues, and fixing all those issues and dealing with it and actually getting it to where it could viably go upstream has taken a lot of iterations. That's actually, this iteration has sat in Linux Next from 6.13, and every time there's always been something coming up last minute that's like, oh no, we need to fix this. And so we're going to push it off another cycle. So we finally actually pushed it in 6.17. It's behind an ABI bump so that you have to get a new version of AppArmor to use it. But it's there now. We have several other things queued up that we have to, if I can get a week, we can get the RFC up for the IPv6 stuff. It's pretty much ready. The user namespace mediation stuff, we need to push a couple RFCs on those as well. We have some IOU ring mediation in, but we don't have it for the new hook or IOU ring command at the moment. Those are waiting to also get posted up. And there's been a lot of little miscellaneous under the hood improvements. We'll cover a couple of them. And there's an AppArmor FS rewrite in the works. There's a whole bunch of not so nice things about AppArmor FS at the moment. And it just is going to be completely rewritten from scratch, basically, so that we can clean that up and make it properly dynamic. It inherited as a kind of a static state from originally being based on security FS, and then kind of hacked in some other stuff on top. So it really needs the rework. Policy-wise, this is one of the places where we've done the most work, though it doesn't show it just at the moment. One of the big things is, and this is very much a work in progress, is the AppArmor.d project is going to be merging in with the AppArmor project. So we're not going to actually take everything. AppArmor.d is still going to exist, but in a very much smaller form as a patch on top. But Alexander, who's on the AppArmor.b project is going to come over and help be a policy maintainer on the AppArmor project as well. So there's a lot of work here to make this integration work better and be able to be used for packaging and be a lot more friendly than it is currently. There's actually an awful lot of work going on here in updating the merging profiles and merging policy and trying to make everything, let's say, cohesive. And it's going to take a lot more work too, unfortunately. One of the things we're going to do is we're actually going to split the policy off from the code. So right now we have in user space, we've been carrying policy in with the user space code in the same repo. We're going to split that out, and the AppArmor.d project is going to move into that. So they'll live in different repos, but they are going to move together. So when we have a major release, we're going to have a major release of policy too. It's only when within the minor releases that they'll float, and you can get updates. Maybe we'll update policy more frequently than the tooling, for example, right? And then the policy itself is going to get set up so that it can be, depending on the system, depending on the distro, split up in different ways for different packaging. So down here, this is shown as like splitting into a core package and a server package and a desktop package. Now, that will be distro dependent. Where how they decide they want to split up policy. It could be one giant blob, except for some individual applications. It could be, lots of different things, a different policy for every application. That'll be a distro decision. To help support this, there's been work on improving the way we can handle conditionals and what conditionals we can handle, Booleans, exporting Booleans on what the kernel supports, what the current parser supports, what the system supports. So, even things like your Etsy OS release type information, so that you can actually do conditionals in policy based on those. So it'll give more freedom on how policy is set up. Better declarations of dependencies between files so that we can track those and automate that kind of thing instead of having to manually deal with that. Better support for individual policy units. So this is kind of like, how do you ship individual or pieces of policy separate from each other? Because, again, how our distros want to slice and dice things up it depends on the distro. Policy overlays is something we're going to natively support finally, so that you can have system policy installed, have a user's local overlay on top of that to change things. It just helps with packaging mostly, so you don't break your packaging when you update your policy. Rule priority was added so that people can actually manually tweak priorities on policy and do more slice and dicing at the rule level where they want things. The unprivileged user namespace restriction, there's still actually a fair bit of work going on here. Not really going to cover much of what we covered last year at LSSEU. But so Qualys, actually, they've been really good to work with. They came to us with three bypasses they found for the user namespace restriction. These weren't surprising because we knew about these when we deployed it. These were deployment choices to make it practical to actually deploy, and then the work is still on trying to make it so we can get it to where we can make it tight enough that we don't have these, right? Not wanting to stay. So like this was deliberately added. So when we were working on deploying the user namespace restriction, we got things like this. We've got the thumbnailer and it's breaking the thumbnailer. We need a way to get past this, right? So we enabled some stuff to do this. And so what it comes down to is we enabled these unconfined profiles as a bypass, right? So Qualys, hey, if we can get into these unconfined profiles, we can bypass it. Yep, no one, right? But again, we need to get to a point where we can remove these, and we've removed them by default. There's still some around that are not. We're still doing work. Have to update packages, update profiles that are not part of the system, so they still exist for those. But it's a work in progress, finishing to remove those. Bubble wrap's sure a pain in the ass. We originally had a profile for it before, when we initially shipped the user namespace restriction, and we actually had to disable it because we broke so many things. And so it's been work to make it so the bubble wrap profile could work. And it's not as tight as we would like it. There's work to improve that needs to be done, but we're actually shipping it and using it. It does break a few things still, and it always will, because bubble wrap is used in awful ways. Environmental filtering. So this one is a work in progress still. This one is the qual-s bypass. We're going to set up and we're going to use the different LD preload to set up the environment so that we can change things and jump to and use that as a bypass to get into an unconfined profile. Again, yeah, if you can do that, you can set up your environment, you can bypass. So from unconfined, we have never had the ability to set the environment scrubbing. So there is some work there to make it so that we can scrub the environment, and that fixes this specific problem. Really, environment scrubbing in general is something that what we have is insufficient right now at the glibc level, the kernel level. So that is actually something that's also being worked on to improve that, because it works for C programs, but it doesn't say, for example, work for the Python environment variables. It doesn't work for different interpreters. And the restrict unconfined change profile. This one's really disappointing, because we actually had the fix for this in when we shipped the user namespace restrictions. It was just disabled because it broke LXD, because LXD does awful things. So we've gotten to the point where we've worked with LXD, and so this is the slide I showed 2 years ago, how we fixed this, that we had the, chosen profile and we could change it and stack it and deal with it. So we've had to work with LXD to get this so that we could enable it. And now this is enabled by default as well. So we're almost done fixing this set of 3 bypasses, at least with the default install. But man, it's been a pain. Other improvements around the user namespace restriction. So capabilities in AppArmor have existed as old code for a long time. They predated the code that actually was doing capabilities. A lot of it was predated, moved to the state machine. So we're talking, I think the original capability stuff, we're talking 2007, 2006, I don't know. So it was just using, a table essentially, which makes it really hard to do some things. So we have landed code upstream to use the state machine for capabilities, which gives us the ability to use conditionals with them. And that's going to be the big change. We still need to land code so we actually have to carry both right now. We still need to land the code that'll do the mapping to support older user space when they don't know how to update and use the new capabilities. But that will come. There's some improved conditional tooling working on when to apply the user namespace restrictions, so we can apply it in different different conditions. Right now, we have a very limited hard-coded condition. We're trying to move from the hard-coded to just regular policy. There's been work around the user namespace restriction is right now hard-coded on unconfined, and there's work to make it so that we can, and this is a long-term work in progress. It's more than one thing, so that we can actually, replace unconfined, use a reduced policy, something else than unconfined here, update applications this way, and selectively apply by policy things instead. And there's virtualization of the Boolean, control Boolean that enables, disables, which we need from a distro integration point of view. Personally, I'd rather have it turned on at the kernel, but there's reasons this is actually turned on by systemd during boot. It's a pain, but and this was brought up ages ago. Is still a work in progress. AA Notify has been updated a whole bunch. It's seen more updates in the last year. We've got landed updates to it just 2 weeks ago even, so that we can let users easily decide that they're going to bypass the restriction, and enable their application, their app image, whatever, because people really don't like it when you block their applications from running. Whoa, losing it again. Permission prompting is one of the places, the Ubuntu permissions prompting is one of the places where there's been a lot of work on the AppArmor side. It's not readily available it's not readily apparent because, well, it kind of right now the AppArmor works kind of locked behind the whole Ubuntu permission prompting. So yes, Ubuntu, you can use it in 24.10 whatever and 25.04, and you can play with it, but it's snaps only, right? We're not going to discuss the whole permission prompting thing. There's a presentation from LSS North America that you can watch if you want that. Ubuntu permission prompting really has 4 components, and it's not a Portals replacement, right? It's designed to cover a specific use case. Portals has their own different use case. So the permission prompting stuff, like I said, 4 components. It's a snapd component, a prompt client, a security center, and the AppArmor bits. Well, the AppArmor bits we're going to focus on, and they can be used as well, parts of it anyways can be used outside of snapd. Currently, snapd is the only client for the notification stuff, but that's not really something else could be written, right? It's just a matter of time. So rules have been extended to say when to use a notification, when to do a prompt, carried in the permission set. That's carried into the kernel. If you don't have a notification daemon running that'll handle this, then it will automatically degrade to default deny. There's been a whole bunch of work around metadata tagging and being able to provide additional information. Again, this stuff it's not for mediation, it's for the user space, it's for the user. And if your kernel doesn't support it, it will get thrown away. But if you do have it, then it can be used for a lot more than just the prompt stuff. This metadata can be used to carry debug information. It can be used to carry context for why something is being denied. So there's, you can improve your denial messages, your audit messages. It's nice to have information. And there's improvements in the caching. So we have AppArmor uses an object cache, FDs, stuff like that, to say, well, yeah, if we've already mediated this thing and, our confinement hasn't changed around this, so we don't need to go and do, any state machine stuff. We don't need to look anything up. We can just fast path out. And there's been some work here to improve this. And that it's tied into the prompting stuff so that, obviously you don't want to reprompt things if you don't need to. The policy around remembering requests and stuff, it's mostly under the daemon's control, but there is a little bit of work in AppArmor on the kernel side itself to be able to remember some things beyond the object cache, and they get flushed on policy updates. The notification thing is on the kernel side it's a queue. you can have multiple listeners. Even like I said, Snapd is the only one right now. But even if you had something, you could have Snapd and something else. It's been set up so that you can have multiple listening, and each one will set up a filter what they're interested in. And then the notifications, they have timeouts on them, and it's all kinds of fun. The use beyond the prompt work here is actually for in profile development for AppArmor. This is going to make it so we can get a lot of our logging out, especially for profile development, out of the audit logs and just deal with it here, and it cleans up a lot of profile development and makes that workflow better. This is work that hasn't landed yet, but there's been a lot of time put into this. So we've talked about delegation for years and how it is built into what we're planning and doing. We've got kind of three types of delegation going on here. We've got an identity delegation, an object delegation, and a rule delegation. So the identity delegation isn't something in security you usually would want, but there are a couple particular use cases. We've run into cases where when you're updating policy, when you want to rename something, you create a new profile, split things that unless you update everything atomically, you get references and things break that, referencing the old names, old identities. And so having this allows for us to migrate and not have that atomic update. We can do it over a migration period and not break things on a live system. It also lets you do migrations over time, even between reboots, where you talk about policy being split apart into different packages, where one package updates and it's still referencing something from an old policy versus the new one, and you don't break that situation. The other place is it actually is used with rule delegation. Well, the rule delegation is because anytime we are going to be delegating rules, think of it like you're augmenting a profile. It changes the profile. We want to be able to identify that it is unique from the base profile. So it actually gets a unique name, but I'm a kind of like an instance of the parent, the actual name, right? And so you can specify it in there. There are a couple possibilities to use it other places, but this is where we are looking at using it right now. The object delegation is basically FD delegation. So tagging FD objects with who opened them, when they opened them, the rules and stuff like that, and then it can consult and say, where are we going to allow this to go? So identity delegation is just about done. It's in review. Object delegation is a work in progress. We hope to have actually landing this fall. And so this will let us to deal with things like FD inheritance, SCM rights in a different way than we currently do. Now, you don't always want to do these things. FD delegation, object delegation does open you up the possibilities of confused deputy attacks if it's used wrong. So there is things we want to do tooling side to be able to check for those type of things where there's a privilege elevation possible and let you know about it. Again, this is not automatic, it's controlled. You'll have rules around this. So you get to make the choice. It's not on by default. It's not the standard Unix, hey, we'll just take your file descriptor and allow you to pass it unless you say close on exec. It's the opposite. It's only if you explicitly allow. And rule delegation, it comes in two forms. Think of it basically as a policy composition. There's what we can do statically. We can compile and combine these things and, hey, load up a single profile that represents both these things together. And then there's times when you actually have something happening at runtime and that composition, and you want to be able to do that. That's the one that's going to land the latest. That's the hardest part of it. But it is a work in progress. We actually might even be able to land the static side of this fall as well. Performance. So there's been an awful lot of work on performance, and there is a lot more coming. It's one of those things you always want to do, but as long as performance is adequate, it gets pushed off, right, for other things. So first one's an interesting little thing. So in AppArmor, we use a critical section in the kernel. You see this in all the code. Well, this is a variation of, this is one of them. But the basic idea is we get our mediation label at the start of this critical section, we do some work, and at the end of the critical section, we finish up with that label. And this is very similar to, it's for a read side lockless type of situation that we're trying to do here. And this is very similar, somewhat similar to an RCU, but we're playing around with creds that have a slightly different constraints on them than RCU. This little change here is made very noticeable performance improvements in the hot paths for certain functions like file open or file permission. And so it doesn't look all that different. We're passing a Boolean in and getting some information out and pushing that Boolean back in. So what's going on and why did it make such a difference? So on the left is the original critical section that we were using. It gets a memory barrier as it grabs the label and checks if it's stale. And if it is, then we're going to grab the newest version of it that replaced it. That's why it was stale. And there's going to be a ref count on it. That's the slow path. That's not going to change in performance with this, really. The fast path is when we don't get the ref count. What happens at the end of the critical section is we do another memory barrier and then a comparison against what the label was. And if it doesn't match, then we're going to put that ref count that we got. So again, that would be slow path. But that memory barrier and that conditional really slows things down because it breaks pipelining. And that's not great for a hot path. What happens with the passing the Boolean in and saying that and updating that Boolean on the read side, the start, lets the compiler optimize this, and even it brings in tail call optimization possibilities as well. So it actually made quite a measurable performance improvement for just that little odd thing. This one, I've talked about this 2 years ago. We're still a work in progress on this. It's all about better sharing, better memory use in the layout. There's a whole file that's doing, compatibility remapping for policy that uses old stuff into the new one. So at runtime, we're trying to get down to reducing the runtime code so everything's in a much more shared format, and it's cleaner runtime code. Will take some hit on the unpack or code policy load side to clean the things up and be smaller and faster. Most of it's actually done. Some of it, like I said, like the capabilities remapping's not done yet. There's a few other pieces like that aren't done yet. State machine improvements. Some of this is fallout from AppArmor.d, and we're talking performance improvements here, really, right? So AppArmor.d currently right now is not fast to compile policy-wise. We're talking, it very much depends on your machine, but we're talking, say, an 11th gen Intel Core i7 type machine. We're talking, if you do it in a serial fashion, about 6 minutes to compile. And if you run it in parallel to compile, you can get it down to about 30 seconds. But that's not great, right? Policy size is also an issue. So we've gone through and we've added some stuff where we can have different sizes on different parts of state machines. Our state machine, we can run shared stuff, we can run separate stuff. So we can have state machines that they take up bigger indexes, 4 billion state type stuff, 24 million state, 64K state. So there's some optimizations there. The optimizations actually play in more than you would imagine due to caching. We'll talk about that in a second. We're also trying to move to more use of differential encoding. This has existed for a while, but it's not really been used. The idea here is a very simplified form. We have like 3 different states, and they have some set of transitions. And a lot of the transitions can be shared between different states, right? In differential encoding, we're going to knock those states out and reference back to previous states, other states, and to pick up what states we need to do. Like state 3, it's got a transition on A to 5. That's masking off state 1 state, so it'll do state 3s, but then it can share the rest of state 1 states type thing, or not the Y, which is also replacing. State 2, is sharing all the states except for 1 where it's doing a whiteout on F, that type of stuff. So we don't have to, so we store less states. This is a way to reduce the size of policy. We're not going to reduce the number of states, but we can reduce the number of transitions. Now, one of the interesting things here is it has a lot of variability to it, right? In the best case, when we're doing it with the current code, compiles can be about 2.2 times faster. And we can get a 50% reduction in policy size, which is great. Worst case, we compile policy and it's almost 2 times slower on the compile, and no reduction in size. So depends on what kind of policy you're compiling. We have some different, mixes that we test, and some pathological test pieces of policy. The averages, that runs for some different types of policy there. Obviously, we don't want to run state differential compression all the time. What we're working right now on is we're playing with heuristics to decide when it's best to use it based on your settings on like whether you want to use smaller policy or whether you want to compile faster, those type of things. So we can dynamically switch these and based on earlier stuff in the compiler pile. Dynamic cast removal. So I've decided dynamic casts are just awful and evil. And it is worse than you might think, right? So we have in our tree expression simplification some code that, because of its nature, actually needs to do dynamic casting or some casting. Dynamic casting, it was using dynamic casting. And the pattern was, we're going to dynamic cast this. And then if it is, if it cast out right, then we'll do something, right? And we switched that over to manually encoding a type in the object, the class, whatever, and doing a static cast. You would not believe how much of a difference this made. It was up to 4.5 times faster. Yeah. Crazy improvement. Other things we have going is user space CREU compression. So our CREU support for policy, for CREU, we actually have to have the policy in the kernel that CREU needs, but we don't. It's not. There's pieces there that aren't usable. And so we don't want that wasting any more memory of kernel memory than we have to. So we compress it. Right now, that's actually being done at load time in the kernel. We want to switch that over to user space doing it. It's just using Z standard, but it's actually faster to do it in user space. And so even just at the same compression level, I know it's weird, we see a performance improvement. The figures, it's not huge. So compressing user space, decompressing kernel is faster than load uncompressed into kernel and compress in kernel at the moment. It was something like 3-4%, but it's tiny, but it's there. But we have better control of trade-offs then. So that was using like a Z standard, I think level 3, where if we switch over and we're still playing with where we want to go with this, and we can make it available in the compiler then and let people tune, is, we can, usually we compile once and it goes to the cache, and then you just reload that cache every time you boot, right? You don't have to redo this. And so you can turn the compression level up. It takes longer to compile the first time, and then you're good. You're fast every time in the kernel. You're using up less memory. So this is going to make some differences for us there. For people who are using Creo anyways. The expert tree refactoring and that was a typo. An expert tree to from moving from a tree to a DAG. These are work. This is work to optimize one phase of the compile. This is where we get most of the state explosion, and so if we can control that at this phase, then our compiles, we can get away from the pathological cases. So all these things are in work. They're just, how close they are to done. We might be able to land some of this stuff this fall. We're getting to where we're starting to get some numbers out of these, but they're not verified or stable enough where we have all the checks. Like the expert tree refactoring, this is a huge one for us, and we're keeping the old algorithm around and the new algorithm, and we're making it so that we can compile policy and run every compile of every piece of policy with both of them and compare them until we're confident that we have it right, and stuff like that. So it's going to take a bit more time, but it should be coming this fall, and it will actually slow down some of the simple policy, but any of the bigger policy, we are looking at some significant improvements. I can't promise anything right now until we get farther down and better numbers on where we're at. This is an interesting one. So there is work towards doing a JIT up call. So I talked a little bit about delegation and the dynamic case for rule delegation. We also do something called stacking. We do this with containers. This is bounding. So with namespaces, you would have seen in LSS North America, SE Linux talking about their namespacing. They do bounding. So what happens is you end up enforcing multiple layers of policy, and that means you have to do multiple layers of policy checks. That has a performance cost. It's not huge, but it's there. And we can, with the state machine we have, we can actually collapse those all down together into a single state machine. So if we decide that we're doing something that needs to be faster for some reason, and there any kind of heuristics you can come up with on that one, then we can take and dump these to user space, let user space compile them together, and load it up as a single unit to replace combining these at runtime. So it's a runtime performance win. The other place where this is interesting is attachments. So if you load policy units separately, it just right now, it makes a set of attachments in a list. And so say you loaded 1,000 profiles all individually, then you have a list with 1,000 profiles, and it has to walk that list and check each one's attachment individually. Well, the way our state machine works is we can actually run all those in parallel as a single check. And it would then be an ON on the input instead of 1,000 times ON, right? Yeah, it's still a constant, but that constant actually adds up. And so we can actually get a performance improvement if we can JIT the attachments. So this is all working towards AppArmor 5, which we're planning to land in January, release in January. We're on an alpha 2 right now. So we've got a ways to go. And most of this stuff, the idea is hopefully we can land everything that's still work in progress here. But, if not, then we were close, and it'll come as a point release. Any questions? Yay. Woo. Yay.